Welcome to Ask and Learn.
In this problem, we have a roller here, and we're trying to pull it over this little step here from the lower surface. And we're pulling in a direction theta with the horizontal. So what we have here is we have a force from the lower surface, but as if we're going to get this over this hump, this lip here, this thing is going to go to zero at the point where this starts to rotate over rise up over this barrier here. So we have our force at 1. I'm going to call this the origin. So actually there's no force there, but I'm calling it V, but we're going to set V equals 0. So that's our origin. Here we have two components, and I should, let me actually read 2x and 2y. 2x, 2y. So we now have our force here acting. We don't know its direction. And we have the position, which we can find from geometry, knowing the radius of this wheel and the height of the step. So the radius of the wheel is 300 millimeters, and the height of the step is 50 millimeters. So this distance here is 250 millimeters. So we can find, we know that it's up 50 millimeters and then over to the left this much from Pythagorean. We have the weight acting at a distance of r up from the origin. And then we have our external load acting here that we're pulling with a magnitude p in this direction. And that we can consider as acting through this point here, because this is just an arm and we're pulling along in the direction of it. And so its position vector we can really consider it just to be at r up from the origin. If we actually consider what this length was and made this here, we would see that this whole vector here would drop out of the problem, because the cross product of it with p would be 0. So we have our forces and displacement or position vectors, and we can sum forces and sum moments, and we have 3 unknowns and p. And it turns out that p equals 272 newtons. We can also get F2x and F2y, and those are 235 newtons and 355 newtons respectively.